Welcome back to the second example on the Clausius-Clapeyron equation, where we determine the heat of vaporization from vapor pressure. We ended off with question 2, and it's the exact same thing as question 1, except we're dealing with a different chemical. The vapor pressure of carbon tetrachloride is measured as a function of time, and the results shown in the table below are obtained. Determine the heat of vaporization of carbon tetrachloride. So using the exact same steps as before, what we have to do is take the inverse of each of these numbers and take the natural logarithm of each of these and plot it on an xy plane. So this is your independent variable x, and this is your dependent variable y. You can use Excel to do this, and unlike in question number 1, I'll actually show you how to use Excel on how to do this. So let's open up Excel. Here we go, and I'll input these numbers really quickly. So now that we've written this in, let's find the reciprocal of each of these. I'll write down equal 1 over, and we'll click this number, press enter. And I'll do the same thing. I'll use the same formula for each, and you should end up with these numbers. Now, to find the natural log of this column, we'll type in equals ln, click the cell, and we end up with the following. And we'll use the exact same formula, so copy, paste, 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 and paste. We will now plot this and this column, and our chart should look like this. We'll also put a straight line, a trend, and we'll make sure that the equation is shown. So here's what I get. This right here is my slope. This is my y-intercept. And just like before, there's a way that you can relate the slope, which in my case is negative 4063.9, with the heat of vaporization and the gas constant. So it turns out that the slope, m, is equal to negative delta H vap over R. Substituting this number into there, I have negative 4063.9 is equal to negative delta H vap over 8.314, which is the gas constant, and that's in joules per mole times Kelvin, and that's also in Kelvin. Multiplying both sides by this number, let's go ahead and do that. Negative 4063.9 times 8.314 divided by negative 1, this thing right here, gives us delta H vap equals 33787. 33787 joules per mole. And if we want this to 3 significant figures, we can stop writing after this 8 and write down 3.38 times 10 to the power of 4 joules per mole. And there you have it. That is how to use the Clausius-Clapeyron equation to determine the heat of vaporization from vapor pressure.